What is meant when the potential difference between 2 points is 1 volt? Suppose I have a point A and a point B, and from point A to a point B I move 1 coulomb of charge, and while moving 1 coulomb of charge I do work equal to 1 joule. Then the potential difference between A and B is equal to 1 volt. So here's the answer. If 1 joule of work is done in moving 1 coulomb of electric charge from one point to another, the potential difference is said to be 1 volt. So again, to explain it, you have a potential difference is work over charge. So if the work done is 1 joule to move 1 coulomb of charge, then we'll have potential difference equal to 1 over 1, which is 1 volt. What do you mean by the term potential difference? What is its SI unit? Now, the difference in electric potential between 2 points is known as a potential difference, and its SI unit is volt. In fact, for potential difference, suppose we have point A and point B. We define the potential difference as the work done to move from point A to point B. We move a charge of 1 coulomb, and the work done is equal to the potential difference. So potential difference is also defined as work done to move 1 coulomb of charge from one point to another. So here I take 1 coulomb charge and I see what is the work done. The work done is a potential difference. To explain it further, suppose I have point A and I have point B, and I move 1 coulomb of charge from point A to B, and while doing so I do work equal to 5 joules. Then the potential difference between A and B is said to be 5 joules. To give you another example, suppose I have a point P and Q, and again I move 1 coulomb of charge from P to Q, and in doing so I do work, say, of 20 joules. In moving the charge from P to Q, I do work of 20 joules. So potential difference between P and Q is said to be 20 joules. Now next, what would happen if I have again 2 points, say A and B, and now I don't move 1 coulomb of charge, but instead I move 10 coulombs of charge. The charge I move is 10 coulombs, and in moving 10 coulombs I do work of, say, 50 joules. Then what would be the potential difference? For that, we see potential difference is work done per unit charge, is work over charge. So here work is 50 and the charge is 10. So the potential difference in this point will be 5 volts. To take up yet another example, here I have again, say, a point, 2 points. I call these points X and Y, and from this point X and Y I move a charge, but not 1 joule or not 1 coulomb. In this case, maybe I move, say, 15 coulombs, and while moving this charge I do a work, say, of 100 joules, then what would be the potential difference? The potential difference is work done over charge, is work per charge, per coulomb. So here 100 joules for 15. So if you now reduce this would be 20 over 3 volts. This would be the potential difference between these 2 points. Which particles constitute electric current in a metallic conductor? And it is the electrons. In a metallic conductor, it is the electrons that constitute current. But however, in a solution, in an aqueous solution or any solution, it is the ions that conduct electricity. So you need to remember this. 1 coulomb of charge, so we have charge which we denote as Q, is 1 coulomb, flows a cross section of a conductor in 1 second. So time is 1, which we say T, is 1 second. What is the current? Now the formula for current is charge per second. So it will be charge over time. Here 1 coulomb charge, 1 second. So this would be 1 ampere. So ampere could be defined as a current when 1 coulomb flows for 1 second. What is the SI unit of electric current? SI unit of electric current is ampere, which is denoted as A. Define electric current. Now, electric current is defined as a flow of electric charges. In solids, they are electrons. And the SI unit of electric current is ampere, denoted as A. Give the symbols of a fixed resistance, a variable resistance, a cell and a battery. So here are some symbols. This is of a cell. A collection of cells, 2 or more cells, is a battery. Then this is a connecting wire. This is a wire joint with 2 wires are joined. This is a symbol where there's a crossing of the wire. They are not joined, they just cross one another. Here we have a fixed resistance. This is a variable resistance and it is called a rheostat, where the resistance keeps changing. This is an ammeter, symbol of an ammeter to measure current, symbol of a voltmeter to measure potential difference. This is a galvanometer, helps to detect current, not measure current but detect current. Here is a switch, an open switch, so current does not pass because the switch is open, the circuit is broken. This is a closed switch. Here is an electric, symbol of an electric bulb. You need to learn all these symbols. Write a formula which relates electric charge, time and electric current. Now electric charge we denote as Q. Time, of course, we denote as T. And electric current we denote as I. And the relationship is I equal to Q over T, means current equal to charge over time. Because current is a rate of flow of charge. Current, the strength of current is, or the magnitude of current is rate of flow of charge with time. Define ampere. First, we must know ampere is the unit of current. And what is the definition of current? Current is Q over T, which means current is charge over time. When do we get 1 ampere? If charge equal to 1 coulomb and time equal to 1 second, then what would happen? We get I equal to 1 over 1, which is equal to 1 ampere. So we'll define ampere as when 1 coulomb of charge flows through any cross section of a conductor in 1 second, the current is said to be 1 ampere. Is 1 ampere. And if you notice here, it is 1 coulomb for 1 second. It is 1 ampere. So let me repeat it again. So current equal to Q over T. So we get 1 ampere if 1 coulomb flows for 1 second. What is a voltmeter? A voltmeter is a device used to measure potential difference between 2 points. Potential difference between 2 points in a circuit. And it is connected in parallel. What do you mean by parallel? If here you have the circuit, here is your resistance. So here is a circuit with a cell, here is a switch. Now if you want to find the potential difference between these 2 points, you need to connect the voltmeter in parallel. So here you will connect your voltmeter. Right? This connection is called parallel. We'll do it in more in detail a little in the chapter, the difference between parallel and series. Now what is an ammeter? An ammeter is a device used to measure current, measure the strength of the current or the current, electric current in a circuit. And this ammeter is always connected in series. Now what do you mean by series? So here if I have a resistance and this is my cell, battery, and I want to measure the current flowing through this circuit. What I do, I connect an ammeter in series, and this will measure my current. Now just to remind you of how did we connect our voltmeter, we connected in parallel this way. This would measure, the voltmeter would measure potential difference. What is an electric circuit? Explain with a diagram. It's a continuous conducting path consisting of wires and other resistances, electric bulbs, etc., and a switch between the 2 terminals of cell or battery, along which an electric current flows. This is an electric circuit. So if you were to draw an electric circuit, you first require a resistance, like maybe you have a bulb, like an electric bulb, which is then connected to a cell, or if you have two cells, it's a battery with a switch, and the current always is denoted from positive to negative. This is an electric circuit. There could be more appliances also attached. What is conventional direction of flow of electric current? Now, the conventional direction of current, flow of current, is from positive terminal to negative terminal, and the actual flow of electrons is from negative to positive.